We know that if the corresponding parts of congruent triangles are congruent, then the triangles themselves are congruent. But what happens if we don't know all the parts of a triangle? There are a couple different postulates we're going to go over in the next few videos that will help us determine if a triangle is congruent to another triangle. The first postulate is the side-side-side congruence postulate. The side-side-side congruence postulate is known short as SSS. And in this video series, it's going to be the 17th postulate that we're going over. SSS says that if the sides of one triangle are congruent to the sides of a second triangle, then the triangles are congruent. Let's draw a picture of that. You can see that side AC is congruent to side ED. Side BC is congruent to side EF. And side AB is congruent to side DF. And since the sides of one triangle are congruent to the sides of a second triangle, then, based on the side-side-side postulate, those two triangles are congruent. And let's make a note that the orientation of the triangle does not affect congruence. The triangles can be flipped, rotated, or moved across the page, but they're still congruent. Let's put this postulate to use in a proof. Here I give you two triangles, AXB and AYB, and I want you to prove that the two triangles are congruent. I have already marked the given information for you in the picture, so let's state that in our proof. From the picture I give you that XB is congruent to YB, and the segment AX is congruent to the segment AY. So now we need to say that AB is congruent to AB. And we know that to be true by the reflexive property. So now we have that the sides of one triangle are congruent to the sides of another triangle. Therefore, the two triangles are congruent. Triangle AXB is congruent to triangle AYB by the side-side-side postulate. And that is what we needed to prove, that the two triangles are congruent.